Dear students, welcome back to online classes. In the last class, finally we have discussed two things. One is a non-magnetic substances, another one is magnetic substances. So in magnetic substances, we are classified into three categories. One is diamagnetic, paramagnetic, ferromagnetic. And in that class, we have seen the relative permeability of those magnetic materials. So and then we have discussed the some examples for the all the substances. So in this class we'll discuss the difference between the those substances, magnetic substances, dia, para and ferromagnetic substances. So let us see here. Let us we will take one example. This is the one of the material. Then for this material, how we can say this is a magnetic material? So it is having the one of the wonderful property, that is MDM. It means if this material has this property, then we can say the material is a magnetic material. So what is this MDM? MDM is means magnetic dipole moment. If any one of the material has this property, then we can say the material is a magnetic material. And we'll tell which material is that we are taking as an example. So that is a diamagnetic, paramagnetic, ferromagnetic. How we can say the magnetic property and in which category it is belongs. So it is depends on the that type of the material. And what will happen here? The electron revolution in the dipole, in the dipole, the electron revolution is in a perfect manner. Then we can say the material is 100% of the magnetic material. So all these things will come under the that property of the material, and which property of the material is there and the type of the material is there, we can see by using these three magnetic substances. And by using these three magnetic substances of the difference, we can understand which type of the materials we are using. That is the examples. So let us see the that first material submagnetic substances, that is paramagnetic substances or characteristics of paramagnetic. So what will happen in the paramagnetic substance? Let us take one magnetic material. Let us take one magnetic material. If you place that magnetic material into the magnetic field, external magnetic field, so the alignment of that magnetic material is in any direction. If it is in any direction, whenever we are applying into the magnetic field, so if you applied the magnetic field to the that material, then the alignment of that material is parallel to the that magnetic field, and then the direction of that material is opposed to the of the that magnetic field. And here what will happen? Whatever the magnetic field lines are there, which is shown by yellow color, so these lines are external magnetic field lines. These lines are passing from n fold to the s fold. It means moving towards the n to the s. And then which is we are placing the material, that material is placing in opposite direction to the that magnetic field lines. And due to the that reason, what will happen? These materials are absorbing all the magnetic field lines nearby the that material. So this is absorb the that material and it is going to be magnetized. So that is the property of this type of the material. So this type of the materials is called as a paramagnetic materials. And the density of the field lines is more here. See here, the nearby, if you are not placing the any magnetic material here, then the field lines are moving like this as a straight line. Now I am placing that magnetic material, and that magnetic material is a paramagnetic material. So then what will happen here? This paramagnetic material is absorb the or attract the that magnetic field lines here inside the data material is shown here, and instead of moving straight line, this instead of moving straight line, the line of that magnetic field is moving into the data material, and these field lines are more, it means the density of the field lines are more in the that material. And xi m it means it is a susceptibility. I have told that the susceptibility, it shows the behavior, how the magnetic material is performs. It means that it shows the behavior of that material. In the paramagnetic materials, the susceptibility is always positive. It is always positive, and its value is small. Why? Because the number of the field lines are, half of the field lines are into the red material and half of the field lines are moving out from the red material. So it means whichever the field lines are near to the that material, those field lines are moving through the that material, and whichever the away from the that material, whichever the magnetic field lines are away from the material, those lines are moving as a straight line. So that's why the xi m is a positive and its value is small. And now here another one, attracted with the magnet, attracted with the magnet. So see here, these are the field lines, and instead of going moving straight line, these field lines are attracted by this magnet, and those field lines are moving from the s to n fold. And next one, that is when a rod is suspended magnetic field, when a rod is suspended in a magnetic field, then it is parallel to the field, then it is parallel to the field. See here, if the magnetic field is sorry, if the magnetic material is like this, if you placed this magnetic material into this field, then what will happen? Automatically, this will turns, and it will make a parallel to the that of the magnetic field lines. So that is the property of this material, which the paramagnetic substances are there. So and the next one is there, that is the xi m is directly, sorry, inversely proportional to the temperature. It means it is not depends on the temperature. If the temperature is high, then the xi m is low. It means it is inversely proportional. And what are the example for this paramagnetic substances? So aluminum, if you place the aluminum, then it is acts like a paramagnetic substance. Calcium and sodium, oxygen at a standard temperature and pressure. So this is about a paramagnetic substances or paramagnetic material. And let us now see next one, that is diamagnetic materials. Now, what is the diamagnetic material? Diamagnetic materials are which the weakly magnetized, which are the weakly magnetized in a direction of opposite to the direction applied to the magnetic field are known as diamagnetic materials. So here the magnet is a repel a magnetic, sorry, diamagnetic materials. If you placed the magnet or magnetic material into the magnetic field, then it is going to be repel in a diamagnetic substances. It means, see here, this is the magnetic material. If I place this magnetic material into the magnetic field, and this magnetic material is less magnetized, and also what will happen, it is going to be repelled by the this magnetic field lines. See here, I have placed the magnetic materials, and the sum of the magnetic field lines are moving straight line. Some of the magnetic field lines are coming up to here, and then it is repelling by the this magnet, and it is moving out from the that magnetic material. So what will happen here, these type of the materials are opposes the that motion of the magnetic field lines. This type of the materials are opposes the magnetic field lines. And see here, this is the n pole and this is the s pole of the that magnetic field lines, direction of the magnetic field line. And what will happen here, these type of the materials, diamagnetic materials, are oppose the magnetic field lines. It means same pole of the material and then magnetic fields are come into the place, and then it gives the opposition. So therefore that's why it is gives the less magnetized. This material is less magnetized in the direction opposite to the external field. So next one is that field lines is less into the that material, field lines is a very less, and chi m is a negative with a small value. So it is opposite to the that magnetic field. So therefore in the that material, the susceptibility is negative with a small value, with a small value. And next point is that repelled by a magnet, repelled by a magnet. See here, if you consider this is a magnet, and this, from this magnet the magnetic field lines are repelled. Repelled, it means it is moving out from the that magnetic material. So next one is rod gets the arranged perpendicular in the external magnetic field. So this rod is, if you place this rod into the magnetic field lines, then the magnetic field lines is perpendicular to the that rod, and the chi m is nearly equals to the change with the temperature. So it is changed with the temperature. And the example for the diamagnetic material, the gold and silver, water and bismuth. So these are the examples of this diamagnetic materials. So now we'll see third one, that is a ferromagnetic materials. So what is the ferromagnetic materials? Ferromagnetism is a material which are strongly magnetized in a direction of applied magnetic field are known as ferromagnetic materials. So what are the example here? Iron, steel, nickel, cobalt, alloys like aluminium plus nickel, cobalt. So this type of the materials is use the ferromagnetic materials. I have written here already. So and now here, more magnetized in the direction of field. It means I have shown the diagram here. So these are called as domains. These are the called as domains. So in a domain, these each domains has a 10 raised to 11 number of the molecules. So in these domains already the magnetic dipole is arranged in a same directions. All the domains, all the molecules are arranged in the same directions. So therefore in this material, in this type of the materials, all the in all domains every molecules in the same direction with those molecules. So therefore here, if you see here, if you see here, if you see here, if you see here, and then in every domains the molecules are arranged in the same direction. So therefore due to this reason, if you placed into the that magnetic field, external magnetic field, then the these magnetic materials are absorbed completely. It means attract completely the magnetic field lines which is passing over the that magnetic material. So due to the that reason, this material is more magnetized in the direction of magnetic field lines. It means this is the magnetic field line. So for this magnetic field line, this is gives the more magnetized material, and the field lines is more. It means if you took a diagram of this material, the field lines, all the field lines are moving from the this material. So therefore this is gives the more magnetized material. So this type of the materials is called as ferromagnetic materials, and the Xi m is a positive with a more value. Xi m is positive and it is more greater than 1. So and then strongly attracted by the magnet, it is gives the strongly attracted by the magnet, and rod is suspended in a magnetic field as a parallel with the direction of the magnetic field line. So and Xi m is a varying with the temperature, and it is a complex way. So therefore the examples of this ferromagnetic material: iron, cobalt, nickel, and you can get a steel also. So these are the three types or three classifications of the magnetic substances. So this is the difference between the diaphragm and ferromagnetic materials. So next one is, I will give a one of the assignment question, that is difference write the difference between dia, para, and ferromagnetic materials. Thank you.